In this universe, one of two possibilities exists. Either we take the high percentage shot and miss, or we hunker down and get shot anyway. Both are equally as terrifying. Xcom is a game all about managing soldiers carefully and strategically across various terrains to put a stop to an alien invasion threatening Earth. Back at the base, there's a lot of crucial decisions that need to be made, whether that's assessing the threat levels of different countries, deciding what to spend your limited budget on, or choosing which mission would best advance the Xcom project. And no matter how well you prepare yourself beforehand, when it comes to the actual combat, standard shots are far from guaranteed to hit. Taking into account impossible difficulty settings, with awkward angles, height advantage and suppression lowering your soldiers' accuracy, things look rather bleak from the outset. If we were to ignore things like grenades, then for the majority of soldiers, once prepared to take the shot, there isn't much you can do about the actual accuracy. There is one exception to this rule, however, that being the assault class with the ability rapid fire. For a trade-off of 15% accuracy, the soldier can take 2 shots instead of 1. This drop in accuracy may not seem like a big deal. You are potentially getting double the damage. However, is it actually worth the sacrifice? It turns out there isn't a blanket solution to all scenarios, but once you have a firm grasp on the situation, you can definitively work out whether it's worth it to take the extra shot. Let's jump into a particular scenario to figure things out. We're here on a standard mission in the petrol station to eliminate all remaining alien hostiles. Scanning the battlefield, we see that the mission's going pretty well. All of our soldiers are alive and pretty well spread out. A lot of aliens have died, and the only one we can see is this floater here, and his weird brother on the roof who seems to have left his jetpack on after he died. The big problem here, however, is that the one floater that is alive is currently staring down one of our soldiers who isn't behind cover and only has 1 health left, meaning that he'll most likely die the next turn. That particular soldier has already made his action for the turn, so he can't run away and get to cover. Therefore it's up to our remaining assault class to try and take out the alien. He himself has moved into this position, so he only has one of 2 options available. He can either take the standard 83% shot, or use rapid fire and take 2 68% shots instead. Before we try to decide which option's best, let's note here that the floater only has 1 HP left, so all we need to do is just guarantee 1 hit to get the kill. Well, I say guarantee, but if we could do that then we wouldn't need to worry about the problem. This, however, is a textbook example of conditional probability. When it comes to the rapid fire option, we have 2 possible good outcomes. The first being that we land the shot on the first hit, or we miss the first shot but we land the shot on the second hit. To describe these events more mathematically, we tend to use the words union and intersection. If we're looking at 2 potential events, then the union of those events is the situation where at least one of them occurs. On the other hand, if we have 2 potential events, the intersection is the instance where both events occur. Our scenario of rapid fire can therefore be described as the event where the first shot misses, intersection, the second shot hits, and all of that is unioned with the event that the first shot hits. Let's have a look at a different probability problem with unions and intersections before trying to unpack this rapid fire question. In this version, we'll simply just consider the case where 2 separate characters are taking a shot. Firstly, we'll ask the question, what is the probability that both soldiers land a hit? Whether or not the first soldier lands a hit has absolutely no bearing on the second soldier's probability of landing their shot. We would consider these 2 shots then independent events, and the probability of both shots landing is simply the multiplication of the 2 probabilities. We can now use this result to work out the probability that at least one of the shots lands. Firstly, let's split the event that Soldier 1 lands the hit into 2 separate scenarios. Scenario 1 is where Soldier 1 lands the hit, but Soldier 2 misses, and Scenario 2 is where both soldiers land their shots. The sum of these 2 therefore is the total probability that Soldier 1 lands their hit, and we can create a similar setup for Soldier 2. Hopefully splitting the problem up like this, you can see that one of the scenarios appears twice. Therefore, to calculate the probability that at least one of the shots lands, we add together the 2 original probabilities, but subtract off one of the overlap cases, which we already calculated earlier on. Now let's return to the scenario where we just need to land 1 hit on this floater to save the other soldier. If our assault class just wants to take his normal shot, he has an 83% chance, which is actually pretty good, but can he do better with rapid fire? The chance of him hitting now drops down to 68%, so if we plug this value into our formula, we have the probability of the first shot landing, which is 0.68, added to the probability of the first shot missing, which is 0.32, multiplied by the probability of the second shot landing, which is again 0.68. This results in a value of 0.8976, which is better than our original first shot, so we're better off using rapid fire. Be sure to remember though that these are just probabilities, and it's perfectly possible that a high probability shot can miss, while a low probability shot can still land. While this is a nice example, it would be a bit laborious to do this calculation every time you wanted to decide whether to use rapid fire or not. Instead, let's take a look at this plot that looks at the probabilities of the 2 different shot types. Our x-axis is the probability of the assault class's single shot landing. Remember that the probability of rapid fire is based off the single shot. Our y-axis therefore tells us what is the probability of the 2 different types of shots landing. Because nothing changes between the initial probability of our single shot and its successive landing, we see on the plot we just have this nice straight line. On the contrary, the calculation we have to do to find our rapid fire success causes us to have this nice little curve. A brief examination of this plot tells us that the closer that the probability is to 50-50, the better our chances are if we use rapid fire. As we move towards the two extremes, 0% and 100%, our chances look better if we just take a single shot. If we think about this for a second, that actually makes a lot of sense. At the upper end, if we already have a 100% chance of landing, why would we risk taking two non-guaranteed hits? And at the other end of the spectrum, if we already have a shot that's close to 0%, we wouldn't want to use rapid fire to turn it into two 0% shots, would we? Although now we have an overall idea of when it's better to use rapid fire and when not to, it would be nice to know those magic numbers when the probability actually does flip in the favour of the other. These 2 points can be found when our two probability formulas are equal. We'll use P here to represent our initial probability, so our formula for our single shot landing is just P. On the other side of the equation, we have our formula as P minus 0.15, the cost of using rapid fire, plus 1 minus P minus 0.15, our probability that our first shot missed, multiplied by P minus 0.15 again. Multiplying out of our brackets and shuffling some terms around a bit, we now have that P is equal to 2.3P minus 0.3225 minus P squared. Then if we subtract the P over, we're left with the polynomial P squared minus 1.3P plus 0.3225 is equal to 0. And finally, we factorise this polynomial. If we're feeling lazy, there are plenty of online applications that will do this for us, or we can use our old friend the quadratic formula. This tells us that any time that our initial probability is between 33.4% and 96.6%, we should use rapid fire. You may be thinking up until this point we've only considered the case where we just need to land any shot because the floater is only at 1 health, but what if we need to do as much damage as possible? Here we move to a similar scenario as we had before, but now the floater is at full health. Now, at the time of recording this, I'm not sure how Xcom decides how much damage it will actually do when the text says up to 5 damage, so for now I'll just assume that it's always 5 damage. To see which option is better here, we use the expected value, which is the average amount of damage we'd expect to see if this situation was repeated lots and lots of times. The calculation for this is very simple, it's just the amount of damage we would deal multiplied by the probability of it actually happening. Our expected value for our single shot therefore would be 0.87 times 5, which is 4.35, and because our two values for rapid fire don't affect one another, our expected value for rapid fire would be 5 times 0.72 plus 5 times 0.72. This gives us a far greater value of 7.2, so clearly we're using rapid fire here as the better option if we want to deal as much damage as possible. Once again, I've generalised the two scenarios and placed them on a plot. Here the y-axis now represents the expected value as opposed to the probability as it did before. This time, however, rapid fire is clearly the better option to use if you want to rack up as much damage as possible. Yes, it may perform worse at low percentages, but you've got to be pretty desperate to be taking those shots anyway. That being said, we can still calculate the magic number where rapid fire does definitively become the best option. The process is a lot more straightforward this time. First, we start off like last time, equating our two formulas for expectation. No nasty square terms appear this time, so a little bit of rearranging tells us that our probability is 0.3. As a little aside, you see here that I left the damage as 5, but if we replace that with just a generic term, you see that they all cancel out anyway, so this 0.3 will always be the case. So there it is, a little summary of when it's best to use rapid fire in Xcom. Of course there are plenty of numbers flying around in this game, and understanding them could be the key to winning. Please discuss any other key calculations that may come up in the comments, and thank you for watching.